All right, we are looking at the activities from day 13, all about interest expense. This is every activity has to do with calculating interest expense. So here we go. So the first activity takes us back to a bond that we looked at in last class, where we issued bonds at a discount. Our 4-year bonds were issued to yield 12%, stated rate of 10%, and the proceeds were generated were $939,253. And I give you some information here about the carrying value. This is definitely information you should understand and tuck away in your head. The carrying value on a bond is always the combination of the face amount, which is in the bond payable account, plus or minus the premium or discount. Remember those accounts? I told you those are basically, think of those as valuation accounts. They always get combined with the bond payable account to give us the carrying value. At the initial measurement date, the carrying value was equal to the fair value because the market set the rate to a fair price. But after that initial measurement date, the carrying value will not be equal to fair value, but instead is going to be equal to what's called amortized cost. That's because the market rate used on the issue date will always be the market rate used in accounting for the bond. Okay, so it's not going to be fair value. To be at fair value, it would have to change in value relative to the changes in the rates, but they're not going to do that. General rule. So the first thing I asked you to do in this activity was to draw a T account for bonds payable and for discount on bonds payable. So that is a pretty basic idea, which I know you can do. So if we were going to look at that, and this is what it would look like. You'd have your bonds payable and your discount on bonds payable. And there's not any amounts there, so let's get the amounts and put in there. So you would have the credit for bonds payable for the face amount, and you have the discount, which, as you recall, is the difference between the $1 million and pull it down here. It's hiding from me. The $1 million face amount and the $939,253 issue price. That's where that discount comes from. It's the difference. So those are our T accounts. We'll come back to those in a moment. And then I said to make sure you could set up an amortization table that looks like this. With the date and the cash paid and the interest expense and the discount amortization. So there's my amortization table. And then we talked about some formulas. We said, what's that formula for calculating the cash paid for interest? And we used that one the other day. That was our stated rate, which I'm abbreviating SR here, times the face amount. So that is the formula for calculating the cash payment for interest. And we talked in class about how you might want to put that on your amortization table, so that you've got the formula handy. And the next question says, what's the formula for calculating interest expense? And here we talked about the fact that we're going to use what's called the effective interest method. And the effective interest method uses the market rate times the carrying value. So we just had a little explanation about what the carrying value is. So that shouldn't be a mystery. So that would be the formula. That'd be the formula for the interest expense. So I'm going to go ahead and put that on my amortization table as well. Copy the whole dang thing. That was not what I wanted to do. All right. Okay. And I ask you to complete that amortization table for the 4 periods. So I am going to get you started on that here. Let's see if I can get these guys to cooperate. Okay. So we started with the amortization table by noting that our initial carrying value is our starting number, the $939,253. That's where the amortization table is going to start. That's our beginning carrying value. And so you can kind of think of that as being at time 0, if you will. Okay, that's the initial date of the bond. So I would say that's time 0. Now we're looking at the end of the first period. So that's going to be, I'm just going to put that year 1. That's not actually a date, but that's what I mean by the end of year 1. My stated rate is going to be the 10% face rate that's given in the problem, and the face amount was $1 million. So if I take $1 million times the stated rate of 10%, I'm going to get a cash paid amount of $100,000, and that is going to be the cash payment, by the way, every single payment of this 4-year loan. So 4 times I'm going to pay an interest payment of $100,000. My interest expense, remember, is based on this formula that we came up with. It is the market rate of interest times the carrying value. So that's the $939,253 is the carrying value. The market rate, if you look back up above, was 12%. So I'm going to take $939,253 times 12%. And when I do that, I am going to get a value of doing some calculating. Okay. 1,112,710. Okay, 1,112,710. That is my interest expense amount. I'll move that over here a little bit. We said the discount amortization is the difference between these two columns. So I can do that math really quick. That's 12,710. And then the last thing I do to update for year 1 is I say, okay, now my carrying value is $939,253. I'm trying to go forward. I know at the end of 4 years my carrying value needs to be $1 million, so I need to add 939. Oops. I need to add 939 and 12,710. And when I do that, I get 951, 9 163. And I would do the same thing for years 2, 3, and 4. So I'm going to do those, and then you can check to make sure your numbers match mine. All right, so there's the amortization table. It's not the prettiest in the world since I did it freehand, but it works. It works. You can check your numbers with it. So I said you want to post those discount entries from the amortization table to the discount T account. So I'm going to move some of this stuff up out of the way so we can do that. All right, let's move this up out of the way. Here's my amortization table. Oops. You get out of the way. All right, here's my T accounts. Now if I take all that amortization, discount amortization, and and copy it down to this T account. You will find, I just now realized this number's not right. You will find that I have this number wrong. We need to fix that number. You guys know that. 939. Instead of being 39, it should be, you're thinking, I thought that all along. Because you're so smart. 60. 607 47. Much better, isn't it? That is much better. Now, if you were to add up all of our amortization, you will see that this basically goes to 0. I know it's not going to go absolutely to 0 because of a rounding difference. Looks like it's going to leave me a 1. But the idea is that it completely goes to 0. Okay, what happens to the discount account balance over time? Increase, decrease, or stay the same? It certainly decreases with every one of these debits. All right, so yeah, it should be going to 0. If you're thinking, oh my gosh, my teacher's crazy, how come her stuff doesn't work? The reason is because I rounded all those numbers instead of using the cents. So it doesn't get exactly to 0, it gets to 1, but you know the idea. So, what's the carrying value at the end of year 4? This is just making sure you understand. At the end of the bond's life, it's got to be the face amount of the bond. All right, that's activity 1. Whew, that took a long time. That's my work page. At the end of the first year, your amortized cost would be, we just did this, and so if you look at your numbers, your amortized cost is $951, $963. It's getting bigger as we move through time. What happens to the discount account over time? We just talked about that. It decreases with each interest payment. All right, activity 2 is asking you to do the same thing, except this time it's bonds at a premium. So you needed to do the amortization table. The only difference is the premium. Look back at the formulas you came up before for how to get cash paid and interest expense. It's exactly the same. I ask you to do the amortization table for year 1. So let's look at that real quick. Yeah, there's the first year, at the end of the first year. And then I ask you to find the present value of $1 million at 8% for 3 years, and the present value of an ordinary annuity of $100,000 at 8 years, at 8% for 3 years. And I'm basically doing that so that you will prove to yourself that $1,051,542 would be the present value of the $1 million face amount with an N of 3 and an interest rate of 8%, plus the $100,000 annuity, which is the interest payment, with an N of 3 and an interest rate of 8%. And I just wanted that to show you how at the end of each of these years, that's what the carrying value is going to be equal to. The amortized cost, or the carrying value, is going to continue to be equal to the present value of the cash flows using your original interest rate and the number of years you have until maturity. So then I ask you to do the amortization table for year 2 and record the entry. So real quick, that's going to look like, if I do another year, 8, 4, 1, 2, 3, this is rolling right along. Let's see if I can do that all at once. Seven, rolling right along, and I come up with 1035. 665 is actually where I'm going to end up based on my rounding. Alright, so there's my year 2. And then I ask you, complete that and record the journal entry. So what journal entry am I talking about there? I am talking about, that's made a mess. I'm talking about the interest expense entry. Good. Well, we kind of need it. We're going to do the interest expense entry, so you know what that's going to look like. We didn't actually do that on the last one, I just realized, but that's okay. That's going to be owner's equity going down. You know that. Anytime I debit an expense account, that makes owner's equity go down. I'm just going to pull the amounts out of my amortization table. So that interest expense was $84,123. I have a premium that we're amortizing, so that is going to happen with a debit. That's going to make my liability smaller. So that's the premium on bonds payable for $15,877. And we also, of course, have to show the cash that went out the door for interest. And that is going to be my 100,000. So I get where I can write it. Okay, so there's my journal entry. There would be the journal entry. What's the amortized cost at the end of year 2? It's right here. Amortized cost. Same thing as carrying value. What amount will show up on the balance sheet for this debt? Right here. The carrying value, the amortized cost. At the end of year 1, your amortized cost was right here. That was the end of year 1. What happened to the premium account over time? Just like the discount account, it decreases with each interest payment. So at the end of the bond's life, the premium account has a 0 balance. Same thing with the discount account. It has to have a 0 balance. All right, we talked a little bit about this, imputing the interest rate. Here I just really am interested in you understand the intuition that if I actually had those debt issue costs, it would lower the amount of cash that I got from $1,066,000 to $1,046,000. And if I got less cash to use, it only makes sense to think that my interest rate has effectively gone up. It's costing me more to use this money, okay, essentially because I got less money to use. So it's more expensive, which just logically then you can conclude that that means I have a higher than 8% rate. You could use the tables, but you're basically guessing. You guess a rate and you try to get the present value using that rate if you were using the tables. So you might guess 9%, and when you did a 9%, you would get a number that was too low. It'd be smaller than $1,046,000. You know the number's not smaller than 8%, so you know it's got to be somewhere in between 8 and 9%. You can do this on your calculator. Basically, you're going to use your inputs into your calculator. You would know the present value is $1,046,243. You know the future value is $1 million. You know the number of periods is 4. You know the payment is $100,000, and what you're solving for is the interest rate. Okay, so rather than solving for present value, now you're just solving for something different. So just an FYI, if you want to use your calculator to do that, your calculator is different than my calculator, so I'm not going to tell you the steps. I'm going to encourage you to, look online. How do I use my calculator? Here's the serial number or whatever, model number, and you'll find it. But if you use your calculator, you would find that rate is going to be 8.5856%. This is the rate you would have to use when you do your amortization table in order to make $1,046,000 go down to $1 million, and to make your premium account of $46,243 go away. See, you'd have to use a higher interest rate. So that was just an intuition activity. Will the imputed interest rate always be higher than the market rate if there are debt issue costs? And the answer there is yes. Company's getting to use less cash, but still has to repay the payments and principal. Okay, so it's always be a higher rate. Which of the following rates are closest to the actual imputed rate? Well, I put it in there and I told you what it was. It's right there. 8% would be too high, 9% would be too low, and if 9% is too low, you wouldn't waste your time looking at 10% because it'd be even lower. All right, activity 3 talked about an effective interest on a 0 coupon bond. So we talked about the fact that for this amortization table, you don't need a column for cash paid. But I said you could put a column of zeros if it makes you feel good. Okay, so here I ask you to do the amortization table. So I'm going to grab an amortization table real quick. There it is. And we're going to get rid of the part we don't need. We don't don't need the cash paid amount, so I'm going to get rid of that. So that would be the form of my amortization table. Okay, so there's the amortization table through the end of year 2. So just to make sure you know where I got my numbers, this is my carrying value to start with. I got the interest expense the same way we've gotten the interest expense before. The interest rate, which in this problem is 12%, times the carrying value. So you can check that math. 12% times 158,87952 is going to give us the 190,6554. The discount is still the difference. It's the difference between 0 and this number. So it's the exact same number. Okay, so the interest expense and the discount amortization are going to be the same amounts. There's no cash paid, remember? Nothing there. And so that discount is going to, remember we add it to the carrying value each time? So if I was going to record the entry for year 2, interest expense, remember there's no actual interest payment. So my interest expense is going to make the owner's equity go down, like it always does, for 2135341. I guess I'm doing year 2. And the liability is going to get bigger. Every time I do an amortization of the discount, I credit the discount account. Bonds payable, and that is going to be my credit here, 2135341. And that would be the entry. What should the amortized cost be at the end of 4 years? Okay, what is it going to be? Based on what we've already seen happen, you know it should end up being the face amount. So your answer is here. It should be $25 million. Should be $25 million. Wow, that's crazy. Face amount. Okay, that's what it should be. You could do it later and to yourself. Okay. What is the carrying amount at the end of year 2? At the end of year 2, carrying amount was this number right here, 19,929,847. How much interest expense would be recognized in total for this 0 coupon bond, assuming you started with that initial carrying value? It is going to be equal to the amount of the discount. Okay, so with the 0 coupon bond, we talked in class about the fact that you essentially all the interest is taken out up front.